Hi everyone, I'm Liwenhan. I'm gonna talk about this TVCG paper on behalf of my co-authors from HKUST, Fudan University, and MSRA. Essentially, we propose to animating word cloud for emotion expression and find a way to help general people create emotional wordles, say Emordles. Wordles or word cloud is a popular visual representation of text data. Its encoding is concise, mapping keywords of a long text into a compact cloud of words, where the text size corresponds to the word frequency. But one issue of this encoding scheme is that the context is not well preserved. Looking at this cloud, it is not easy to tell the tone or the underlying emotion, compared with reading to the original text. So we asked, can we augment the wordle design so that the emotional context can be naturally expressed? Like when someone sees it, they just know the emotion without going into details, just the way how we interpret a painting or music. In the literature, there have been some approaches to embed qualitative information on data VIS, such as the outline shape for semantic context, color palette, font, and animation scheme for particular emotion types. And we come across many excellent designs of kinetic typography here and there in films, lyric videos, and ads. The motion or deformation of text effectively delivers subtle emotion. Like the first example builds tension, the second communicates melancholy, and the third example conveys a cheerful mood. With these inspirations, we seek to animating wordles for emotion expression. But how? What are the building blocks of animated text so that it is still easy for people to create wordles? And how to reliably inject emotions in the design of text animation? To address these questions, we first investigate kinetic typography design in the wild. We curated a corpus with 77 instances available online and conducted content analysis. And we derive a design space with two levels, local and global changes on text elements, 4 dimensions of changes, including the text scale, its position, deformation of the typeface shape, and the external styles like color, texture, and so on. Time control is also an important dimension concerning the duration of keyframes and the transitions between frames. In terms of strategies to inject emotions, we extracted 3 themes. The first is to mimic real-life scenarios. This example here moves the letter I to the corner and makes it tremble, resembling being afraid. The second strategy is to portray linguistic styles. Like in this example, the text size corresponds to the speaker's volume. And the last is to manipulate speed and randomness, where there are multiple text elements. Inspired by these examples, we propose a composite approach where we regard an animated wordle a composition of multiple animated text. There is a backbone animation scheme for each text element, meaning that they share a similar animation pattern, but there will be slight variations so that we can play with randomness, namely entropy. Accordingly, we designed 4 backbone animations based on the qualitative coding. Here we use the fading effect as an example. With different speed and entropy, here shows 4 variations based on the backbone animation. The entropy refers to the number of groups randomly assigned to the words, but there are more. All 4 cases are similar, yet varying in the extent of sadness. For my personal interpretation, the slowest one looks depressed and dignified. With faster speed, it becomes dumbhearted and disturbed. When the entropy gets larger, the disturbance increases, going into melancholy. But when the speed goes up, it is less heavy and conveys unpleasant mood. So with entropy and speed, I, as a creator, can tweak the animation details and arrive at the best match for the intended emotion. In summary, our approach allows general users to create Emordle in 2 steps. First, selecting the backbone animation, and second, tweaking the animation detail for different levels of emotion. To capture the full emotion space, as illustrated in this figure, we envision an ecosystem where designers can contribute to effective design of backbone animations and appropriate representation of entropy. We also develop a user interface for authors on Emordle integrating the 4 design cases. Users can upload their data, customize the static styles, select backbone animations, and adjust the entropy and speed while previewing the effect. Here showcases several examples applying our approach for suggesting happiness, sadness, anger, and fear. Recall that we have assumed a backbone animation will anchor the emotion type, and tweaking entropy and speed may fine-tune the emotion extent. It is still unknown whether this assumption holds and whether end users are accustomed to the 2 steps. Therefore, we conduct several crowdsourcing studies to verify the approach and run a user study to understand user experience. First, we set out to see whether people can recognize the emotion type given one animation scheme. There are 2 sub-studies. The first one is quite challenging, masking out semantics in the data, and simply ask what emotion it is for this animation. Participants have a level of consensus and attain hit rate better than random guess. The second one gets more realistic, using synonyms of emotion name as data and ask which animation scheme best fits the semantics. And participants achieve a hit rate no less than 50%. Then we ask participants to compare outputs of different entropy speed configuration. And we found that under each of the 4 backbone animation, there is a significant difference in the rating of emotion extent. As for the authoring experience, participants recognized the entertaining and engaging effect of animated Emordle. Besides, they found it easy to create an Emordle matching the intended emotion. However, they criticized the limited template choices and expressed hope for more editorial layers like sound integration for more compelling video making. There are 2 major limitations of this study and requires more future works. First, end users may not foresee the outcome of the entropy configuration. More guidance is expected to navigate them in the candidate animation scheme. Second, the success of an Emordle heavily relies on the backbone animation design. It is still unclear what contributes to the most effective design and requires significant design expertise. Future works may dive deep into different design factors and investigate generative design to automate the process. As a preliminary work, we had a paper about transferring cross-domain animation design onto text to appear on VIS. In summary, this paper reveals that randomness introduces nuances in emotion expression. And we demonstrate that we may augment the emotion expression of a given visualization by animating the unused visual channels, like the position and scales in our design cases of Wordles. As data features also relates to audience emotion response, how to better support effective visualization authoring remains an ongoing research direction. Thank you for your interest. For more information, please refer to the paper or reach out to us.